Hello guys, welcome to another lecture on queues, and in this lecture I will be discussing about the types of queues and their applications. The basic has been covered in the previous lecture. So types of queues are three: circular queues, decks and priority queues. Sometimes this is also pronounced as DQs, but since we have studied DQs as one of the operations of removing the elements from the queues, therefore for now and for further references we will be calling this as decks. So circular key is something that we have discussed in the previous lecture while we discuss about the array implementation of the queues and the shortcomings that it has and how the circular queues outdo that shortcoming. So just for revision, let's have a very quick look at the circular queues. So circular queues means that there is an array where the last element of the array the next element to the last element of the array is basically the first element. So that way it is the circular array. So the queue could be maintained over here, and in order to have arrays as queues, we need to have two variables, rear and front. They both are initialized to the first cell, and when we are inserting or enqueuing any element, the rear moves and goes all the way through the n number of values of the array. Once it reaches the boundary and it finds that there is no space available, this is an overflow condition. But if suppose a dequeue operation is called at this point, so dequeue, since it is a queue, it will be dequeuing the first element that entered into that queue, right? So the first element out of all these 5 elements was A. So if I'm calling a dequeue function, so A will get removed from the list because it is FIFO, first in first out, right? And now if there is again an enqueue operation, enqueuF, so see, it is not ending over here, but after 5 it is now connected to 1. So F will get added to the first location, and likewise it moves on. For details you can refer to the previous lecture. Decks. Now decks is data structures which is also called as doubly ended queues. So what happens in case of decks is that we can enter or we can insert or remove the elements from both the ends. So we can insert from the right hand, we can delete from the right hand, we can insert from the left hand, and we can delete also from the left hand. So both the operations can be performed from both the ends, but we cannot insert और वी कैन नॉट डिलीट एनी एलिमेंट इन मिडिल. बीच में से नहीं कर सकते. एंड्स में इंसर्शन डिलीशन दोनों साइड से हो सकता है. एंड दीज आर ऑल्सो द सर्कुलर क्यूज. दैट मीन्स दैट व्हेन राइट इज इंसर्टिंग द वैल्यूज एंड इट रीचेस द nth location, after the nth location it wraps around and goes to the first location. So it's a circular queue. And similar is the case with left. When it is inserting the value, it is moving in the left hand direction, and once it reaches the first location, it will be wrapped up to the nth location. If it is free, then the next element would be entered in the nth location. So left will always move in the left hand direction while inserting. Right will always move in the right hand direction while it is inserting the values. Fine. And these decks are of two types. The first one is input restricted decks. In input restricted, as the name suggests, we have a restriction on the insertion. Insertion can be performed only from one end, and deletion can be performed from both the ends. But if I want to restrict my deletion, then it is called as output restricted deck, where deletion can be performed from any one end only and insertion is allowed from both the ends. If explicitly it is not mentioned that what kind of a deck it is, we will assume that we can add and remove the elements from both the ends, assuming that the basic data structure for implementation is a circular queue where there will be two variables, left and right. Left would be used to insert the values in the left hand direction, and right would be used to insert the values in the right hand side direction, and similarly for deleting the values as well. Let's see an example. Let us assume there is a circular queue of size 6, and we have got two variables, left and right. Initially they are initialized to 0, but as soon as there is an enqueue operation, there is addition of any element, they will be initialized to 1, and from the first location itself they will start feeding the data into the circular queue. So if my first command is that I want to insert B, A, C and D, these 4 elements towards the right. Right means this right variable would be incremented while entering the value into the circular queue. Fine. So B would be inserted at this location, then right always moves in the right hand side direction. So the next cell is 2, 3 and 4. So these 4 cells will be filled up by the values that I want, that is B, A, C, D, and right will be pointing towards the 4th cell. Now if I say a command delete one letter from the left, now this left will come into play and it will delete a letter. And while the left is deleting a letter, so that pretty much means that B would get deleted. And after deleted, where should the left go? Left would be incremented and move towards the right hand side, right? So left should be pointing towards A after this statement, and this is what it does. Now if I say add F to right, what does that mean? That this right variable will be moving one step towards the right hand direction to add the value. Now see, right when moves right, it adds the value. Left, when it moves right, it is basically deleting the values, and vice versa. When it is inserting, it moves in the left hand side direction. When right is deleting, it moves in the left hand side direction. Okay. So add F to right means on the 5th location, F would be written and right will be pointing towards the 5th location. If I say delete 2 letters from right, so what does that mean? Now this time right will be decremented by 2 values and it will be reaching 3, thereby deleting 2 values F and D. If I want to add K, L, M to left, so left has got this one place over here, so K can be inserted here, but is there a place for L and M? Yes, it is, because I said it is a circular queue. So after 1, it will be wrapping around to the last location, right? It is also free. So K should come over here, L should come over here, and M should come over here, right? And left would be pointing towards the latest entered element. So left is now pointing towards the M. So there could be a condition where the value of left, that is 5, is more than the value of right, which is perfectly fine. And this is fine, and there is no overflow until this left is equals to right plus 1. So that means left can still grow if it wants without causing an overflow. If I say delete one letter from left, that means left is pointing towards the M, and now this M should be deleted. So it got deleted and now it has moved to the L. Add R to left, that means an R would be added towards the left. So when you are adding the value towards the left, so left again moves to the 5th location. Add S to right, that means right would be moving in the right hand direction, thereby inserting the value S. Add T to right, now what would happen? Right would be inserting a value only if there is a space. So before inserting the value, you have to check if left is equals to right plus 1. If that is the case, it's an overflow. So you will display overflow and no new element would be inserted. Alright, so this is how decks are managed. The task for you here is, I have mentioned through an example an overflow condition. Can you generate an example where deck can cause an underflow as well? So this is your task. Through an example, explain if deck has underflow conditions or not. Priority queues. Now priority queues are just normal queues, but the elements here have got certain priority. It pretty much gives you a sense. Now you will not be entering the data in one queue, but there will be a number of queues which is dependent upon the levels of priority that you have. So before going to the rules, let me just clarify a few things. Priority could be like, if you define priority to be high, medium and low, so that means you need to maintain 3 queues, one for taking the elements of highest priority, one queue for taking the elements of the medium priority, and one for taking the values of the lowest priority. If you say that you have got priority levels 1, 2, 3, 4 and 5, that means you will be now managing 5 queues. And this is what we'll be doing, seeing through the example as well. Just keep in mind, the lower the priority number, the highest the priority is. If I'm saying this is my priority 1 task, that means it is the highest priority task. If I'm saying this is my priority 2 task, that means this is the second highest priority task. So with number, priority is not increasing. With the decreasing numbers, the priority is increasing, and this is an assumption that I am making for explaining the things in the coming slides. So 5 has got the least priority, 1 has got the most priority. Keeping that in mind, the rules of the priority queue is that an element of higher priority is processed before any element of the lower priority. Right? So whatever elements are there in the queue of priority 1, they will be processed first. Until and unless all the values of the highest priority element are solved, you will not move to the second priority queue. Okay? Two elements with the same priority are processed according to the order in which they were added to the queue. This says that if there are three elements and all have got the second priority, so they will be member of the second queue. And while they are the member of the second queue, out of these three, which one will have the precedence? The one that came first, because queue is basically first in, first out. The one that came first would be the first one to get processed. So if there are two elements, both have got different priorities, it's very simple to select which one will be processed first. But if both the elements have got the same priority, then you have to check which one came first, and that should be processed. So simple queue would be applied over there. The best example is the time sharing system. In time sharing system, the different people are running different programs on their system. So programs have got their priority levels. So program with the higher priority will be processed first and will be maintained inside the queue, right? And the lower one will go to the lower priority. Implementation of the priority queue with the array. So as we said earlier, priority means it gives me an idea that there will be separate queues for different priority levels. So circular queues for every level of the priority should be created, and the front and rear information of each queue should be maintained. So let's look at an example. Here we have got 5 priority levels. This is the highest priority, this is the lowest priority. And whenever there is an element that is being inserted, so with the element you need to know the priority of that element as well. So if I say that okay, I want to enter G and G has got the second priority, then you go to the row number 2 and insert the value of G. Now the value G would be managed by, the insertions would be managed by the rear value, and the dequeue operation or deletion would be managed by the front values. So you need to keep a track of the front and the rear values for each queue. So therefore I have a list over here of the front and the rears with for each queues. So priority 1, there is only one element, so the front and rear is same, that is 2 and 2. In priority 2 we have got 3 elements, so we have got the front as 1 and rear as 3. There are no elements in 3, so front and rear are 0. Here we have got 2 elements, the front is at 4 and rear is at 5, so 4 and 5. And here you will see that priority 5 has got one element at the first location and one at the 6. Now in queues, you know that you cannot have a big void in between. The elements would be in the contiguous memory location, and that is the very much requirement of array as well, right? So it has to be continuous. That pretty much means that this is not the first element and this is not the last element, rather this is the front, and since it is a circular queue, the next element has come to the first location. Therefore the front is 6 and the rear is 1, because the elements have to be contiguous. Alright. So if I want to insert an element, so pretty much I have an idea that insertion, I just don't need the item, but I also need to know the priority. So if I say that okay, I want to insert K at priority 4, so what you need to do, you have to write a program of insertion into the queue that we have discussed in the previous lecture. But before that you have to identify which queue you want to insert it to. So this priority value P will be deciding that which queue you would be entering the value to. If I am saying K4, K and 4, that means you go to the Q4, priority 4, and there find the value of rear, and at rear plus 1 store the value K. So insertion is same as the queue, but where would you want to insert would be selected by the value P. If you want to delete the value, deletion is considerably an easy task over here. For deletion, you have to start from the first row. You have to find if the first row or the highest priority row is not vacant. Then in that case, you have to dequeue the elements of that queue. If suppose row 1 was empty, then you move on to row 2 and you dequeue or remove one of the elements. If they are consecutive 4 dequeues, for example, so the first element that gets out is A, the second element that gets out is B, the third element is F, and the fourth element is G, and then so on and so forth. So the deletion would be that find the first row where front is not equals to 0, means find the first row where you have got an element. Delete and process the first element. So you have found the row, and suppose a row number is K where there is an element, you go to that row, delete the element from there. Priority queue with linked list. Now in linked list of the priority queue, there will be a little change in the structure. So for whatever node we studied, we had a data element over there and a pointer element over there to point towards the next node. Here, since the priority is also associated, so along with the data, I also have to have a priority element. And if you remember, in linked list, I told, you can refer to that lecture as well, that while you are creating the structure, it is not mandatory that you can only have data and the pointer part. You can have any number of data and then you can have one pointer that points to the next node. Fine. So here, this is one of the classic examples of that case only. Here you have got a character type data, an integer type priority, and a pointer type value for the next pointer. Fine. So in order to define such a structure, you have to use struct node char data int prrt. Now this is the variable that I'll be using for the priority and next for storing the address of the next node. Okay. And by convention, we have been using temp name for the new node that we are creating, and then we are initializing the value of temp. So temp data part would have the value that the user want to enter, and then temp priority will be the value pri which is entered by the user. So prrt will be taking the value from the pri. This is similar to saying that item comma p for insertion. Now, since this is the first element that has got in, so before writing the data and PRRT part, if I ask you a question, what is the function that is used to create this node? It's malloc, right? So with the help of the malloc, I have created a node. I have named it as temp, and then I have written the data as well in the data and the priority sections. And after that, I'll check whether this is the first element or not. So for that, if start is equals to null, that means this is the first element that we have received, and therefore we do not have any start value. So this will be my starting point, right? So if start is equals to null, then temp next should be equals to start. That is, the next part of this temp should be equals to null, because start is equals to null, and therefore a null would be written over here. And then you make start equals to temp. Sorry, the spelling mistake is there, so it should be TEMP. So this becomes a start also. Now later on, we have got a linked list where there are 4 nodes, namely A, B, C, and D values, and this has got priority 1, this has got priority 2, 2, and 4. So if I look at the element that I have created, or the node that I have created right now, it has got the priority 3. So where does it fit in the existing linked list? So you will realize that this is a third priority. So it should come after priority 2 and before priority 4. So it should come over here. That means this node should be pointing towards the temp, and temp next should be pointing towards this node, right? So this is what we want to do, and we want to remove this link from here. For that, it is important that I somehow reach to this location as well. For that, I'll be using the head as we have been using in the linked list programs. So when start is not equals to null, that means I have got a linked list already in place, and start is pointing towards the first node. Then you go to the else part, and head is equals to start, so you have a head variable as well. Then you can write a while loop, and while loop that head should move to the next node if it is not null. So if head next is not null, then the loop should be true. And besides that, it also compares the priority value of the next node and the temp that you have entered. So this priority 3 is represented by PRI, and this expression over here, head next. Head next is what? Head next is 5x, this location. So 5x ka PRRT is 2. So you compare 2 with the PRI, that is 3. So 2 is less than the PRI. That means the new node priority is more than the priority of the next node. Therefore, you have to continue the loop by moving head one step forward. So when head comes to this point, it will again check that head next, that is 9x, is it a null value? No. That means there are more elements to come later on. And head next priority, go to head next, this is 9x, priority 2 is still less than the new element, and therefore head should move to the next location. So likewise, head will move towards this node finally, where this condition still holds true, that head next is not equals to null. Yes, the next is not equals to null because it is 2x, but head next priority, so head next is 2x, the priority is 4. Now this priority is not less than 3, right? Neither it is equals to 3. So this loop ends over here and head is not moving forward any further. And now you'll get an idea that head has already reached to the node after which I want to enter the temp. So this task is similar to the task that we have discussed while discussing the insertion in the linked list at a random location, and that too after a certain node. Right? So we have reached a node, and after this we want to insert an element. So what changes am I supposed to make? First of all, I want that temp next should point towards the last node, and this address is with head next. So temp next should be equals to head next. So therefore 2x would come over here and this would be pointing towards the last node. Now I would like to change the value of head next. Head next should be equals to temp, and therefore this value would get replaced by 1x. So this way I have inserted a node based on the priority value. Okay. Let's see one more example of insertion itself. The sequence of node is same. There is an node A, B, C and D with priority 1, 2, 2 and 4 respectively. It is exactly same as the previous case, but this time I have got a new element E, but this time this has got a priority 2. So where to keep this priority 2 if I ask you this question? So priority 2 would definitely not come before 1, so it will be after 1 itself. But after 1, can I keep it here? No, I cannot, because if you remember the insertion of queues in case of linked list, it was always at the tail that you add the element. So for same priority, we will add the new element at the tail. Why? Because these two have already come first. First come, first out. Therefore, they will be maintained towards the left hand side. Whatever new element comes of the same priority should be added towards the tail. Right? So again, this node would be taking a place in between C and D. Fine. So I have entered the values. I have used the malloc function to create the temp, suppose, and now again if start equals to null, which is not true because start is already having a value. So you go to the else part, you create another variable head which is pointing towards the start. Now again you have to write the same loop where head is next is not equals to null, and the next node's priority is less than or equals to the priority. So head next is 5x. 5x priority is equals to the temp. So the loop continues and head moves on until head reaches a point where the next node's priority is greater than the priority of the new node. Okay, so this condition over here less than or equals to does the job for me. That for same priority also it continues the loop so that I reach towards the tail, and then at the tail an element should be inserted. Now here the first task is that the temp next should be pointing towards the 2x, and 2x value is with head. So temp next is equals to head next. Fine. Now head next should be equals to temp. And this is how the node will get inserted into the right position, or you can say tail of the same preference order. So now your task is that insertion was a tricky part, so I have told or discussed the insertion. I want you to design the algorithm for deletion of the node. If I want to delete, what steps in these terms I would be writing. I don't want you to write the complete program. What I want that you write these steps as per the requirement in the deletion mode. You need not have temp because you are not creating any new node. You can only delete an existing node. So just discuss how the deletion process would take place. You can take the example of this linked list over here. Applications. The applications of queues are multifold. One of them is categorizing of data. So example, I've written router queuing. Categorizing of data is again somewhat dependent on priority queuing. So you have got routers in your network, and whenever you are generating a message and forwarding it, it is through routers that the message gets forwarded, and all the messages first are divided into the packets of something called as header information, and from the header information you get whether what kind of service are you looking for, what is the priority of that particular packet. So every packet can have a different priority as managed by the network administrator. So at router certain decisions are to be made looking at the content of the header, right? So that header is read from the packet, and based on that, if it is identified that the packet is a higher priority queue, so a separate queue is maintained for higher priority. So you are categorizing to which particular queue that packet should be added. If it is getting added to the higher priority queue, then definitely it will be processed first. Fine. And then there are several algorithms that what should be the order of their process, and that should not lead to starving and all. So let's keep that aside. So categorizing is one thing that we can do with the queues. Another example could be that there are suppose 40 numbers, and I want to classify those numbers that whether they belong to 0 to 49, 50 to 99, 100 to 100, 149, or 150 to 200. What range are they lying? Right? I want them to be part of those queues which are managing the data of that domain. So suppose it is the Q1 is managing the data from 0 to 49. So anything that is between 0 to 49 should be kept in Q1, and Q2 is managing the data of 50 to 99. So everything that is between 50 to 99 should be placed in Q2. So that way also we can use a queue for categorizing of data. Second example could be queue simulation. That means we have been talking about that ticket counter queue is the example of the queue, a real life example of the queue. You go to a restaurant and you stand in the line, you get a token, and then you get the service from that restaurant and the food that you have ordered and all based on a token. So it is all queue. The first person who comes into the restaurant will be the first person who get the service, right? So if I want to simulate that environment, I will be using the queues once again, right? For example, I will be creating the queues in order to manage the data of the incoming customers, that what number of customers and in what order have they come. So whenever there is a new customer, I would be putting that customer in the queue. Now, since I'm talking about simulation, so there will be no real data. So what I can do is I can have a random number generator, and that random number would generate any value. And if I say that if the value thus generated is 4, then I'll assume that a customer has come to the restaurant. As soon as the new customer has arrived, I have to check whether the server or the person who takes the order is free or not. So that is my third point, free server. If the person who is taking the order or the person who provides the service is free, the customer goes to that server and places the order. If you are the second or the third or the fifth customer, and there is already customers in the queue, and there is already a customer with the server, who is placing an order over there, that means you have to wait in the queue. So any new customer would be added to a queue, and you may record the clock timing as well, at what time have the customers arrived and at what time they were called by the server for taking the service order, right? So you can manage a queue that whenever a customer reaches a server for the order, it has to be a queue once again. And once the service has been completed, the food has been delivered, you can again note a time that at this time you have supplied the material or the food or whatever it is, but still again it will be in a queue, that the first time customer would get the order first, then the second and third, and so forth. And at the last you can have a displaying option where you can display the statistics. So when you're simulating such a thing, everywhere when where a data is coming, whether it be in the form of a new customer or in the form of the data being placed, order being placed for the food, always there will be a queue at the background that would be helping us in simulating this real world scenario. With this, I would like to end the lecture. Thank you.